Hello and welcome to the Answer Series Natural Sciences videos based on our study guides. In this video, we will practice what we have learned throughout this topic by working through an exam type question. Now, a basic understanding of chemistry is provided up to grade 8, so the questions and answers in this exercise are provided on a grade 8 level. But there may be some more complexity added as you progress through the grades. So here we have models 1 to 4 representing the chemical composition of 4 different compounds. And what they've provided you with is a picture of the model, as well as the chemical symbols of the elements in each one and the name. So we can see number 1 is copper chloride, number 2 is calcium carbonate, number 3 is called ozone, and number 4 is water. Pause the video here and try to answer the questions yourself before we work through the answers together. Question 1 asks you to define a term, pure substance. And this is something that requires you to merely recall the definition from your notes that you've studied. A pure substance is matter that has a constant composition and it cannot be broken down by physical means. Question 2. Give the names of the following elements that are present in some of the compounds provided. So they give you the symbols and you need to provide the names. Cu is copper, Ca is calcium, and the H stands for hydrogen. Give only the number of the group on the periodic table where A, chlorine is present, and B, oxygen is present. So to answer this question, you would take the periodic table that you will always have handy with any exam. You are given a periodic table. Certain information on it will just not be available, like, for example, the names of the elements. You will only receive the abbreviations. So if you look at your periodic table, you'll go all the way down to group 17, and there you will find chlorine. And oxygen, you will see, is in the group next to it, number 16. Provide the atomic number of oxygen and copper. So again, for this, you would use your periodic table. Now, the first step is to remember what the symbol for oxygen is. That is an O. So you locate the O on the periodic table and you see that the atomic number, according to your key that's provided, is the 8. So oxygen has an atomic number of 8. Copper has a chemical formula Cu. You've already determined that in question 2. So you look for Cu on your periodic table and the atomic number for copper is 29. Question 5 is another definition for an atom. And again, you would just remember this from what you've studied, that an atom is the smallest building block of matter. Question 6 asks you to describe the location of A, protons, and B, electrons in an atom. So we remember from what we've discussed that protons occur within the nucleus of an atom. And electrons are like moths or insects attracted to the light, which is this nucleus. So electrons are found around or outside the nucleus in an area called the electron cloud. Question 7. How many protons and electrons does a neutral atom of calcium have? So to answer this question, we first need to find calcium on our periodic table. So from question 2, you've already determined that the symbol for calcium is Ca. So finding calcium on the periodic table shows you an atomic number for calcium of 20. So that means that a neutral atom of calcium will have 20 protons and 20 electrons, because that atomic number tells us how many protons are present. And if an atom is neutral, it will have an equal number of positive and negative charges, an equal number of protons and electrons. So question 8 now asks you to explain how you determined your answer in question 7. And this is important because basically you're going to tell them the methodology that you followed. So you're going to say that the atomic number of an element, that's 1 mark, gives you the number of protons in an atom of that element. That's the second mark. Then you get a third mark for saying that when the atom is neutral, it will also have the same number of electrons. And now you need to make this applicable to calcium, because the question asked you, how did you determine this for calcium? So that means calcium's atomic number is 20, and therefore you will have 20 protons and 20 electrons. And you will most likely not get a mark for that last sentence, therefore it has 20 protons and 20 electrons each, because that is something you've already answered in question 7. So you can say that a question like number 8 would have counted a maximum of 4 marks. Pause the video here and try to answer the questions yourself before we work through the answers together. Question 9. Ozone consists of 3 oxygen atoms that are chemically bonded, and you can see that in the diagram of molecule number 3. It's also called a triatomic molecule. What do you call a molecule where 2 of the same atoms are chemically bonded? So here the question is trying to help you. It tells you that ozone has 3 oxygen atoms, and it's called a triatomic molecule. So the tri obviously refers to 3. And you learned that a molecule that has 2 of the same atoms that are chemically bonded together will be a diatomic molecule, where that di at the beginning means 2 of the same. Question B says that besides oxygen, give us 2 other examples of elements that form the type of molecule you have just mentioned in question 9a. You learned about nitrogen, chlorine, and hydrogen. And notice the memo says any 2, which also means that the teacher will also mark the first 2 only. Because the question specifically asks you for 2 examples, even if you wrote down all 3, they will only mark the first 2. Question C. Would ozone be considered a molecule of an element or a molecule of a compound? And it asks you to explain your answer. So if we look at ozone, we're going to see 3 of the same atoms chemically bonded together. And we know that an element is a pure substance because it consists of repeating numbers of the same atom, whereas a compound consists of different atoms bonded together in a fixed ratio. So this is definitely a molecule of an element, and the main reason is because we can see only one kind of atom. There's only one element present in ozone, namely oxygen. Question 10. Give only the number or numbers, it could be more than one, of the compound or compounds that can be physically separated. None of these 4 models or compounds provided can be physically separated. Physical separation only applies to mixtures where there has been no chemical bonding between the different things that have been added together. So you can still separate them through physical means like hand sorting or sieving or filtration, etc. But because these 4 models show you compounds, and we know that compounds are pure substances, we know that the whole point of it being a pure substance is that it cannot be physically separated. So none of these can. Question 11, give only the number or numbers of the compound or compounds that can be chemically separated. So if you remember, chemical separation can happen to molecules of compounds. Molecules of elements cannot be physically or chemically separated because there's nothing to separate it into. It consists of only one kind of atom, so you can't really break it down into original elements because it's still going to be the same thing, and you can't break it down into other elements or other compounds. So if we look at our 4 options, that immediately removes number 3, ozone, as an option to our answer, because ozone is a molecule of an element. So again, it can't be physically or chemically separated. That leaves us with numbers 1, 2, and 4. And if we look at those, all 3 of them can be chemically separated because they are molecules of compounds. Molecules of compounds are pure substances, so they can't be physically separated, but they can be chemically separated Think, for example, of the copper chloride that we broke down using electrical energy, electrolysis, and the potassium permanganate that we broke down partially using heat energy. Question 12. Now we're getting to an application of knowledge, because this is an example that you have not been introduced to and that you're not familiar with. So you can see that this whole exercise is building on from your easier questions to your more difficult questions, and you need to practice those higher order thinking skills. A teaspoon of calcium carbonate is mixed in cold water. Most of the calcium carbonate does not dissolve in the water, and you can see it floating in the water or sinking down to the bottom of the beaker. So that is a very crucial statement that basically tells you that there's no chemical reaction that's taking place here yet. So if question A says, is this mixture of calcium carbonate and water still considered to be a pure substance? The answer there is no. It's not a pure substance because it literally is defined as a mixture. And mixtures aren't pure substances. Then it says to list two differences between a mixture and a compound. Now this is something you can just remember from what you've studied. Simple examples would be that mixtures do not have a fixed ratio of different types of atoms. Compounds do have a fixed ratio of different types of atoms. Another option could be that mixtures can be physically separated. We've just said that, but compounds cannot be physically separated. A third option, mixtures consist of different molecules or different elements and different compounds, all thrown together, whereas a compound consists of one kind of molecule that repeats. And then lastly, you can also say that mixtures are not pure substances, but compounds are pure substances. So definitely the fourth and the second option here would be your easier ones to recall, but you could have listed any two of these differences. And again, just regarding exam techniques, if the question asks you to list two things, the examiner, your teacher, is only going to mark the first two things you list. So you could have written any of these differences, any two of them, but the first two would have been marked. Also important is to note that you have to list a difference, which means that you have to give a comparison within your sentence. You can't just say mixtures do not have a fixed ratio of different types of atoms and expect to get your mark, because you're not saying anything about the compounds, and you can't expect the teacher to read into your answer that they now assume you mean that compounds then do have a fixed ratio of different types of atoms. Pause the video here and try to answer the questions yourself before we work through the answers together. Question 13. Copper chloride can be separated into its elements using electrolysis. What type of energy is used to break a compound down during electrolysis? And you can actually read it in the name, because we said electrolysis, the electro refers to electricity and lysis means to break. So we're using electrical energy to break the chemical bonds. List any two requirements for electrolysis. We need first and foremost an electrolyte. We need two electrodes. You could have specified an anode and a cathode, or a positive and a negative electrode, but it's very important that you don't just say an electrode, because you can't perform electrolysis with just one. So you need two electrodes. And then you need an electric current that could be subdivided into a battery and connecting wires. So because the question asked you to list two things, once again, the instruction is to mark any two of these correct, but only the first two that you provide. Question C, briefly describe what you would observe during this decomposition reaction at the cathode. Right, so this requires you to now think back to what the cathode is. So if you remember, the cathode is the negative electrode. If you remember that, you immediately note that it's going to attract the positive element in copper chloride, and that would be the copper part, the metal, which has the positive charge. So what you would observe needs to be described, meaning you can't just write one word. You need to give me a sentence. What would you see happening at the cathode is that a red-brown copper precipitate would form at the cathode. And that's a very important description. You tell me the color, red-brown, you tell me the cause, copper, and you tell me that I can see it because it's a precipitate that forms at the cathode. Then it asks you to explain what you would observe during the decomposition reaction at the anode. So I included these two questions for you to see very clearly that there's a difference between the answer given for a briefly describe question, you're just giving a description of what you've seen, and now you're asked to explain what you observe. So you would technically also have to state what you observe happening at the anode, but you would have to give an explanation for what you observe as well. So when it comes to an explain answer, you normally follow a because this, therefore that answer technique. Because of this particular chemical reaction, this is what I observe. So you can structure your answer the other way around. You can start by describing what you observe and then providing an explanation for it, or you can do it the way that I've done it on the memo. So we'll look at both options. So I like a because this, therefore that. So that starts with chlorine has a negative charge, right? Because chlorine has a negative charge, it is attracted to the positive anode. And because of this, therefore, chlorine gas is going to form at the anode. So what do you observe? Bubbles forming around the anode. And those bubbles escape. So you have chlorine gas that is escaping, and you'll notice that bleach-like clean swimming pool smell, which is characteristic of chlorine. So that's because this, therefore that. You tell me what is the properties of chlorine, therefore you observe X, Y, and Z at the anode. If you do it the other way around, you start by stating your observation. So you say chlorine gas forms at the anode, so you see bubbles. And as the gas bubbles escape, you get this bleach-like smell, which is characteristic of chlorine. Why does this occur? Because chlorine has a negative charge and it is attracted to the anode, which has a positive charge. Question 14. When calcium carbonate is added to water and heated to boiling point, it breaks down due to thermal decomposition. So we had the calcium carbonate in a previous question, 12, where it was just mixed with the water, but now it's being heated and it breaks down due to thermal decomposition. The word equation is provided. Calcium carbonate changes to calcium oxide and carbon dioxide. Okay, so now they ask you a question that you are not expected to know, so it requires of you to think a bit for yourself. What do you think is meant by thermal decomposition? So we talked about the concept of decomposition, where we're breaking something down into its elements, and thermal here obviously refers to the addition of heat. So if electrolysis refers to the use of electricity to break something down, thermal decomposition refers to a reaction that uses heat energy to break the compound down. Name the gas that is released during the thermal decomposition reaction shown above. So they expect you to know that carbon dioxide is a gas, and you learned that in your life sciences component during term 1. Then the last question, potassium permanganate can also be broken down partially using this method. So that was another hint. If you didn't know what thermal decomposition meant, you would have thought, oh, potassium permanganate, we used heat energy, so that must be what thermal decomposition means. Then it asks you to name the gas that is released during this reaction, the potassium permanganate reaction, and how you would test for the presence of the gas. So you must remember that potassium permanganate breaks down partially to release oxygen, and you test for the presence of oxygen with a glowing wooden splint. It will spontaneously relight or reignite when oxygen is present.
Check out the video description below for practice questions from our study guides. If you found this video useful, give it a like and subscribe to our channel so you don't miss any new episodes. Follow us on Instagram or Facebook to stay on top of the latest TAS news and launches. So that's it for now from the Answer Series, your key to exam success.